Okay, so to review our power rule that is so fabulous, we've proven once and for all that if we have ax to the n to take the derivative, now we don't have to go through the whole. I mean, it's not that you're never going to have to go back to definition of derivative, you will sometimes, but when you're allowed to, and you're allowed to right now, you can use the power rule. So you multiply the n times the a, and then you subtract 1 from the exponent. All right, number 1 on your homework, use the graph to estimate the slope of the tangent line at x to the n power at the point 1, 1. Verify your answer analytically. All right, so they gave me some kind of like little graph paper here to where I can estimate it and can maybe assume like what's going on up 1, maybe over 2. So maybe I'd estimate that the slope of the tangent line at that point is 1/2. Then I'll verify it analytically. And so now it's take the derivative using the power rule. And so if I had, by the way, if you had square root of x, you would want to make it x to the 1/2 power. So you bring down your power, 1/2, multiply it to what's in the front, which right now is just 1. Then you subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. So the slope is 1 over 2x to the 1/2. Something I'll be telling you to clean or fix up your derivatives, clean up your derivatives, is the first thing you want to do is take care of the negative exponents. So I have 1 over 2 root x. And at the point 1, 1, I could say the derivative or the slope of the tangent line at x equals 1 would be 1 over 2 square root of 1, be 1/2. So there's my estimate, and this shows my work, and we do it at x equals 1, and we get the slope as 1/2. Okay, so next, let's see, number 5. All right, on number 5, this is great. So we're going to find the derivative. Oh my goodness, it's so much better than doing the definition of derivative. You're just going to bring this down and say 7x to the 6th. One like this, like number 7 and 9, the key is you have to write it as a power. You just need x to the n for this to work. So just a hint on number 7, when you do it, you're going to make this x to the negative 5 and then take your derivative. So you'd bring this down and subtract 1. On 9, you would make this x to the 1/5. To take your derivative, you bring that down and subtract 1. The derivative of 11, do we have 11? Okay, so I'll do 11 for you. You make sure you do 7 and 9. 11 is kind of like, you'll be kind of mad I did it because it's so easy, but I wanted to talk about it. You bring your 1 down and you get 1 x to the 0 because you subtract 1. And the derivative of a constant is always 0. If you remember your definition of derivative, they always cancel out. Now you can verify this would be the slope of the tangent line because this thing right here is just a line. Y equals x plus 11. The rate of change is always up 1 over 1, up 1 over 1. Let's see. 13. 19. Just looking to see if you might need help on some of these. Oh, okay. I didn't tell you the derivatives yet of sine and cosine. I'll prove those later. But let's just write them down. If you have sine of x, the derivative is cosine x. And if you have cosine x, the derivative is negative sine x. And right now, just memorize those. I'll explain why that is later. But on 19, I'll do it over here. You have a coefficient pi over 2, and the derivative of sine is negative cosine, and follow your variable, and the derivative of cosine is negative sine. So I get negative pi over 2 cosine theta plus sine theta. Like I said, I'll go through a proof of sine and cosine later, but just to look at it is kind of interesting. Well, we'll just do that in class. So just memorize them for now. You know that I'm going to prove them to you. And we'll learn the other ones also. We'll go over our trig derivatives. So I did 19 for you, right? 27, 29. Let's see, I don't remember if I gave you any more trig derivatives right now. 27. So we want to rewrite it. So we want this y equals 6 times 5x to the third power. Oh, I'm sorry, the -3. So we want to bring this up so that we have it just as a ax to the n power. Since we brought it up, we call it -3. Differentiate, bring down your -3. So that gives me, oh, you know what? Sorry. We have to simplify it even more before we start. This is 6 over 125 x to the third. So to rewrite it, I'm going to make it 6 over 125 x to the -3. You needed this as a coefficient. You needed to get rid of that composite function. Now to differentiate, I bring a -3 down in front. So I have -3 times 6 over 125, which is -18 over 125. And then you subtract 1 from the exponent, so you get x to the -4. And then to simplify it, we usually drop our negative exponent back down. It says 27. So if you have something like this one, you would make this 2/3 x to the -2 to rewrite it. This one would be 5/2 x to the -2. All right. Where's 29? Okay, you've got to write it as just one expression before you can do this y. You have to have an, excuse me, that form before you have to have just like a single power to bring it down in front and subtract 1 using the power rule. So I've got to rewrite this. So this is x to the 1/2 over x to the first. And then you subtract your exponent, so you get x to the -1/2. Then you differentiate. Bring your -1/2 down in front, subtract 1. And then to simplify, get rid of your negative exponent. Simplifying, we're going to work a lot on next week. -1 over 2, x to the 3/2. So I just drop my negative exponent back down. All right, 35, 43. All right, you're going to have to FOIL this out first. You can't have what's called a composite function. Sorry, I can't get out of that. There. Well. All right, you've got to have it written like a string of numbers. So before you do 35, I'll FOIL this out. We give you 16x squared plus 8x plus 1, and then take the derivative. I kind of didn't do that one. You got to finish it. And you're finding the slope at the given point. So when you take the derivatives, then you're going to fill in 0 for x, and you'll have the slope. So check your answers. 43. You've got to have it written simply. Like for instance, if you were doing 41, you'd write this t squared minus 4t to the -3. You got to have everything on the top. So this one all has an x in it. So I'm going to reduce and make it 4x squared plus 3x. And then take my derivative. Like if I was doing 44, I would have to make this x minus 6x to the -2. Here, I'd have to put x into everything. Here, I would have to distribute, and so on and so forth. You've got to get it written as just like a string. So you'll have to finish 43, 53, 57, and 93. 53, I'll let you try that. You should be okay. Let's see, I lost my place. Where did You hit undo, I don't know, okay. 57, to make sure you do that one. And then on 92. So I've done a lot of them for you.